All right, DAX variables. DAX variables are great for organizing your measures in columns, but do come with a caveat. When using variables, they are evaluated first and treated statically after initiation. So let's express sum of total reviews with a variable. Each statement with a variable requires a return statement. The return statement can either be an expression or a reference a variable. Not every variable has to be used in the return statement. So if we go to total reviews, and we can just say var, which is what we have to use to instantiate a variable, and we call this total. We can then do return total, and that's basically how you use a variable. Now, this is kind of silly, you might as well call it equation, but this comes in handy when you're trying to do a little bit more complicated. So if we go to our average reviews calc, for example, what we can do is we can split this up a little. And we can say var reviews, total reviews, var count hosts equals, or sorry, var hosts equals count hosts. And then down here, we can return our divide statement and call our variables instead of the other DAX functions. So this can be useful, particularly when you have a long, complicated DAX equation and you need to kind of separate the parts into various logical cells. As you type the DAX, it recognizes the var and thus color codes your variable name. This makes it easy to identify the various objects in your DAX. Teal is for variables, purple is for other measures, red is for text, and black is the default color. Now, if we chart our average reviews measure, we'll see that they're still equal. We did it. Page 3. Whatever, we'll do it again. Average reviews, we can take our average reviews calc, and they're the same. We throw it across dim host ID, host names, same values. So variables don't really, generally are pretty easy to use. But let's show an example of how using a variable causes the value to be static. First, we'll use a variable as a filter. So this is kind of where it's going to get a little complicated. We're going to go to dim room, and we're going to create a new measure called rooms above median latitude. So rooms above median lat, and we're going to go var dcount equals the distinct count of dim room, and in this case we'll do dim room name, and then var median latitude, we're going to call the average of the dim room latitude, and then var number of rooms is going to calculate dcount, our variable. We're going to filter where dim room, I pressed enter a little too early. Dim room latitude has to be greater than our median latitude. And from here, we're going to return the num rooms. I'll leave that up for a second. It's a little bit longer. And then we're going to plot it against neighborhood. All right, but what happens? Let's I want to show why the variable is going to be slightly different than if you just used the D count right in this equation. So we do new measure and we do rooms above medium latitude, but we're going to drop a 2 after it just to show it's a different equation. We're going to take this distinct count, we're going to copy it, and we're going to replace D count here by just calling distinct count. Ah, you're right. I should have used median. You're right. Good catch, Sally. Right here we could do median. Just write median. Oh, not median X, median. Alrighty. Basically similar, but you're right. Median latitude makes a little more sense. So what I did is we changed it here, and we're using distinct count D count here. And then I created a duplicate function, but this time instead of calling D count, I literally called the equation again. So in this case, you can get rid of this variable because we're calling the equation directly. Now we would expect that these equations are the same, right? If you use a variable and it's just like a variable and it takes the place of something, shouldn't the values be the same? Well, here's some tricky little conundrum. You drag it in and the values are different, right? So we can dig in a little bit. What I'm going to do is I'm going to show you a third equation, rooms above median latitude 3, which might kind of shine some light on what's actually being said. So if we do rooms above median latitude 3, but this time we just have var, the number of rooms, equals calculate distinct count dim room name. So none of that median stuff, right? We just do enter. And we show this in here. We can actually see it's equal to our first rooms above median latitude, which is the one that used the variable, right? So what we can conclude really is this equation is fairly easy to read. It's really just the distinct count, the calculate really has no function. The distinct count of the number of rooms per neighborhood. What we can say is even with this median latitude and this filter, it has no bearing on the distinct count up here, even when we use it here. And that's because this part of the equation, this distinct count, is calculated at the context at which it's addressed, which in this case, the host or the neighborhood is giving it this context. So it calculates the distinct count per neighborhood, and then it's static. It's treated like a hard-coded number then. And so really what this number room says is calculate this hard-coded number and then filter it, but it's a hard-coded number, you can't filter it, and so it just returns the hard-coded number. So yes, the variables are nice because they color code your DAX, they make it look clean, you can indent, you can organize your calculations. But it's important to understand that sometimes you can do it too much, that this might throw your calculation off, that the actual correct equation is the rooms above median latitude 2. You need the value to be calculated along with the filter. I hope that made sense. So that's an example of when using a variable might lead you down the wrong path. Now, I also have an example using calculated tables to show you where you need to use a variable in order to get the right answer. So DAX can also be used to create calculated tables. Calculated tables are tables based on hard-coded inputs or references to pre-existing tables. This is particularly useful when you want to create a summary or aggregation of another table, but don't want to reload the table in Power Query. It can also be used to join values from disparate fact tables to make a conform dimension. In this lab, we'll go over the usage of variables in tables. You can learn more about calculated tables in our next DAX lab. I'll be really going over summarize and all of those things. Um, but if you want, I really created this example from studying the following example from SQL BI. So if you want to see the original, that's kind of where I got this idea. But for now, what we're going to do is we're going to create a simple table using the filter function, and then we'll filter the neighborhoods and their count of rooms for only rooms above the overall median latitude, right? So first, what I'm going to do is I'm going to go to Table Tools. I'm going to go to New Table, and this is going to ask for a DAX input for a table, as opposed to a column, as opposed to a measure. This is a DAX table. And so my equation is filtered rooms, summarize. We're going to filter dim room by dim room latitude is greater or equal to calculate the median dim room latitude over all rooms, comma, dim room neighborhood group. Then we're going to do a, in quotes, count of rooms, comma, distinct count dim room name. So kind of explaining this kind of inner to outer. The real equation in this is the distinct count of dim room names, and that's fairly straightforward. This is the label, so this is going to be the column header for this new. Imagine that we're creating a table, and this is just a column in it. So this is the label or header for this column. Then the other columns I want are neighborhood and neighborhood group. And this table, these three columns are going to come from this table. This table is going to take the dim room table, and I'm going to filter it where the latitude is greater than the median latitude for all rooms. So if I look at all the rooms, I take the median latitude, I'm only going to return the rows of the dim room table that meet that criteria. And then from there, I want the neighborhood group, and the distinct count of rooms per neighborhood. And that's what this entire function does. And what we can do, nice thing about calculated tables and calculated columns is you can see your results in the data view. So if we go to filtered rooms, we can see indeed we have those three columns, neighborhood group, and the count of rooms. And we only got those rooms that are above the median latitude. However, what if we want to show the counts based on medians of a particular neighborhood as opposed to the global New York median? Remember, we're looking at Airbnb houses in New York City. So what if we want to do it by a particular neighborhood? We can kind of modify, we'll create a new table for this, and we'll call it filtered rooms Harlem. And I can wrap my entire function in a calculate table. Then we can have our summarize. We will, calculate that table. And then all we're going to do is add a filter at the bottom, dim room neighborhood. Oh, neighborhood group, sorry, is equal to quotes Harlem. End quotes. Or end parenthesis. Did I do that right? Something's off. Did I spell Harlem wrong or something? Sorry, I'm wondering if I should be getting back some rows. Calculate table, summarize, filter, dim room latitude, median of the latitude for all rooms, 3 ending parentheses, then we want the neighborhood group, the count of rooms, distinct count, in Harlem. Maybe it's neighborhood. Ah. In my example, I posted the wrong screenshot. Harlem only has it's one neighborhood in Manhattan. Let's do Manhattan. And let's change this group to Manhattan. I will have to edit this later. All right, so filtered rooms Manhattan. And if you look here, when we look at our table, we have 26 rows. Let's go back to the filtered rooms table, and let's filter by Manhattan here. And we get 26 rows. Now, if you remember what the task was, it was to show all the rooms that are above the median of Manhattan, right? So how could all of if you look and if we order by count of rooms, for example, you'll notice that it's the exact same rows, right? So it's not like all of the rooms could be above the median. By definition, this doesn't make sense. That's not like that's how medians work, right? And the issue is that the inner median calculation, it's really just like exactly what we did. You take that table and then you filter by Manhattan. This inner median calculation, especially with the all dim room filter here, is going to escape the filter from the outside. So what we can do instead of it being addressed at, using the all function here to show all the rooms, we can use a variable to calculate at a specific context. So let's copy our entire function really quick, and let's make a Manhattan 2. Sorry, we're going to do new table. Oh, guess I didn't copy it correctly. We'll do Manhattan 2. And here, instead of the calculate median, we're going to do a variable here called median lat. And I'm going to do median, dim room latitude. That gives us the median. And what's interesting I found about this example is you can do a return here in the middle. I forgot an ending parenthesis. But your return doesn't necessarily have to be like at the end of a function, but you can return in the middle of the function, or rather the function returns something, right? And then you automatically call that function. Um, so here we can do the summarize, and then instead of this calculation with the all statement here, we can take advantage of the variable being called at a certain context. This parenthesis there. And you'll see now we have a 12 row table with different number of rooms as it's only counting the rooms above the median. So just as a challenge question, if you're interested, how could we verify these results using DAX? So maybe something to think of. How could you verify that these are in fact the number of rooms above the median? You could use, DAX measures, DAX columns, just think of various ways. You should be comfortable enough with DAX to express what you want. And if this means using DAX to do data validations, that's a very important skill set. So consider there's a way to validate this using DAX. Other DAX, right? Different rows to the same answer. And then also, if you're interested in this kind of stuff, this level of coding in DAX and bringing this amount of value to your company or your clients, please join me for the next webinar. It's basically going to be exclusively about this kind of advanced DAX concepts. With that being said, we will kind of take it back to some easier material, and then we'll wrap this up. So I'm gonna just jump right. Do any of you have any questions before I jump into calculated columns? Do you need me to explain anything about the DAX tables or measures or show some things on the screen? No? All right. We'll just jump right into calculated columns. Feel free to shoot some questions in the chat if you need. Um, calculated columns are pretty straightforward. They operate on a row by row basis, and that's what we'll be doing for this, the extent of this lab. Given certain columns to operate on, it takes on the values of those columns in a particular row, evaluates, and spits out an answer as the value for your new column. This works with text. Say we want to take the P plus period plus space plus FY plus year. It's also easy to understand mathematical functions, e.g. revenue minus cost equals profit. Or if you divide profit by the cost column, you'll get the margin column. But for this lab, we'll stick to the basics. Calculated columns can get more complicated when we consider changing context like we just did. We'll save that for the next lab. So text functions like left, right, concat, and etc. work similarly how they do for measures. However, because calculated columns operate on a row by row basis, there is no need for first non-blank or last non-blank. So let's go to dim room and let's create a couple columns. We go 3 dots, then we go to new column. So let's do an example using left example. We'll say left dim room neighborhood. We'll do 1. You'll see we get the H in Harlem for our neighborhood. We can do this again for a new column. We can do a left 2 example. Similar how we did the left 3 example, we'll do a left 2 example. And we should get the HA in Harlem. Alrighty. And now let's do a right example. Dim room, new column. And I'm going to take off this. I'm going to do right example, but this time I will do the right 3. Alrighty, that makes sense, right? So left and right are like the equivalents of first and last. We don't need the first non-blank, last non-blank with inside these equations to make it work because a calculated column operates row by row. So for this one, it's going to output this one. If we scroll down and we find some other examples, for example, it's going to operate this one on a row by row basis and push out, boo and ick. So let's do an example with concat. We can call this Buick, for example. I mean, obviously for other rows, it's going to be something else, but we can do Buick equals let concat left to example and right example. And we got at the top, the HA and the LEM goes to Halem. If we go down, we find our BUs. Oh, we passed it. Well, I guess we're going to have to search for it, huh? But we get our Buicks here. And we can also, also add some hard-coded, similar to what we did before. We can do concat with, without using the concat. We can do it with and symbols. So here we could call it the boo-booick, right? So maybe we do the left example. I do and, we can do a space, do and, we could do that left to example again, and then we could do and we could do that right example to get a boo-booick, a bee-booick, which is a left to example. Boo-booick, right? I mean, obviously this is nonsense, but the point is to show how easy it is to do calculated columns. It's pretty easy to understand. Similarly, math functions are pretty simple. We can go to ABCNY 2019 to do some math functions. We might do one for a minimum total price. So what people might be getting themselves into if they book a certain place. In this case, we'll be looking at price. And then we can multiply by the minimum nights. And you can notice that I'm simply typing, when I'm going through, I'm typing the column name. DAX columns are specific to a table, right? Because they have to be annualized row by row in by particular columns in that table. So the fast way to write it is just call out your column names because it already knows what table you're talking about. In this case, we can see that, for $100 a night, for a minimum of one night, the minimum you're going to pay is 100. We can also use other basic math functions such as like addition, subtraction, multiplication, and division. We can even use hard-coded values. So we can do a minimum nights plus 1. So extra night. Oop. 3 dots, new column. Extra night equals minimum nights plus 1. Right? Pretty easy. And then if we enter just a static value, whether this is a text or whether this is a number, if there is no column reference, it's going to give you that static value. We can call this 24, for example, equals 24. Every single row will have the value 24. I'm going to give you a little sneak peek of how to use context with calculate. So let's say we use calculate minimum price, for example. New column. We'll call this calculate calc minimum price. Calculate. Now, because use calculate, it expects an expression, not a column. And so I have to do a sum before it. And I might do minimum price here, or sum of price. Now, you might expect it to do the total price, but what it does is it takes the sum at each row, right? And similarly, if we take this and we do a new column and we add that all filter in there, so we do calc minimum total price, or calc min all price, for example, and we do a calculate, and we're going to do sum of price, and then I might do all ABNY 2019. We're going to get, all of the prices. Now, and if we want to do a group by, what we want to do is we want to use the function all except for a kind of, if we want to get like the minimum price from, let's say, whatever the host ID is, right? So we might do calc min all host price. So, or min from host price. So if we want to take into account just the host, we're going to do a calculate sum price, then all except, and we'll do AB, and then we got to do host ID in here. So kind of like that. I think I need a parenthesis after my sum, and then I'll find a specific example to show you. So keep in mind, these values are static, right? But if we find a host, let's do organize this descending, for example. If we find a host with multiple values, we'll see that this value changes based on who the host is. And that's it.